Water is a resource that humans depend on for survival. So we're going to look at where those water resources are and how they are distributed. So first of all, let's talk about how we use fresh water. The number one use, 70% of fresh water on Earth is used for irrigation, and so that goes to produce the food that we need for our growing population. 20% of it is used for industry, and usually that's in cooling processes. And then the other 10% is what we use in our homes for drinking water, for flushing the toilet, taking a shower, washing clothes, and so on. So where the water comes from, it is a continuous cycle from the water cycle, which is driven by solar energy. But our source of water is either surface water or groundwater. If you're on city water, you get your water from Falls Lake, which is a reservoir that was created behind a dam. If you are not on the City of Raleigh water, then chances are you have a well, which is dug down into what we call an aquifer, that is rock layers below ground that store groundwater. So in this module, we're just going to be looking at surface water. So those are our rivers, our lakes, and our reservoirs. So starting with the rivers, the head of the river is usually the higher elevation, and any snow melt or rainfall is going to create small gullies that run into small streams. Those small streams run together to create larger rivers, and ultimately that flows into the ocean. And we extract that water at many places along the way. So a stream or a river is anything that's continuously moving in one direction. Starts at the headwaters, usually from snow melts. It could be a spring, which is where groundwater comes to the surface, or some rivers even start from lakes. Then they travel all the way to their mouth, which is either where it runs into another river or a larger body of water like the ocean. So we're going to look at 3 different life zones within a stream or river: the source zone, the transition zone, and the floodplain. So all of the land that feeds water into a river is called a drainage basin. You'll also hear them called watersheds. We are in the Neuse River Basin, so all of the water that hits the ground whenever it rains eventually ends up in the Neuse River. And then sometimes you'll have smaller rivers that feed into larger ones. The Mississippi is an example of this. So if you're looking at this map, the Mississippi River Drainage Basin covers this entire area of the United States, east of the Rockies and west of the Appalachians. So all of these smaller rivers run into the Mississippi River, and the delta of the Mississippi River is down here in Louisiana. All right, so starting at the source zone, that's in the higher elevations. We've got faster running water. Usually the riverbed is narrow. Transition zone, you're in your lower elevations. You've got more water. They tend to be a little bit more shallow because the rivers slow down, the sediments sink to the bottom. Then you have your floodplain zone. This is almost to the mouth of the river. You're getting close to sea level, so the water's moving very slowly. It's called the floodplain zone because the river is so shallow. You can see here the sandbar. When there is a little bit extra rain or extra snow melt, it very quickly floods its banks, and the entire floodplain area is covered in water. All right, so looking at these 2 pictures right here, these are satellite images of the Mississippi River. This is during normal flow, and this would be during one of the floods. Here's another before and after of the Mississippi, regular flow and during flooding. Now, floodplains are very fertile farmland because when the river floods its banks, the extra silt and sediments get deposited, which add nutrients to the soil. So a lot of times you'll see farms in these areas, even though they do run the risk of being flooded periodically. But that's one of those examples where the benefits outweigh the risk. All right, so switching gears to ponds and lakes from rivers and streams. So ponds and lakes are not continuously moving. They are when fresh water, either from rainfall, from runoff, or even spring-fed from groundwater, fills depressions in the ground. So ponds are smaller. Some are seasonal, meaning sometimes they're completely dry and sometimes they're filled with water. They tend to be shallow enough that sunlight can penetrate all the way to the bottom. So we say they have one zone. Lakes are much larger. They last longer, hundreds of years or more. They have 3 zones, and we're going to look at what those zones are, and they're defined by the depth and the distance to the shore. All right, so looking at this diagram, your littoral zone is your shoreline. That's the shallow area, and it extends pretty much to where the vegetation stops growing. Your limnetic zone, that's going to be your open lake, where most of your fish are, most of your larger organisms. The surface part of the limnetic zone is lit. And then the deep lake bottom, that's the profundal zone. You're not going to have any vegetation because there's no sunlight. It is high in nutrients because you have all of the decaying material from the rest of the lake sinks to the bottom. All right, so depending on the amount of nutrients in the lake, we can classify it as either oligotrophic or eutrophic. Eutrophic should be a term that's familiar to you because we've talked about eutrophication, which is when you have too many nutrients in your body of water. So oligotrophic are usually newer formed, so they tend to have rocky bottoms instead of muddy bottoms. Not very many plant nutrients because there's not a lot of plant material. And they tend to have a very pretty blue or green tint to their water. Now, eutrophic lakes, those that have excessive supplies of nutrients, so they're going to have that pond scum, that algae growth. Lots of organic material, so it decays, sinks to the bottom, you get that muddy water. They tend to be more shallow, all of the organic material that fills up the lake bottom. So they're very murky. This is a side profile of eutrophication. Now, there's both natural and cultural eutrophication. Anytime you hear the term cultural, that means human caused, similar to anthropogenic. So natural takes centuries to go from oligotrophic to eutrophic. And that's just natural processes, the sediments filling up the bottom of the lake or pond. Whereas cultural eutrophication takes decades, and you can see all the buildup of factories and farms and cities leads to the runoff. Because anytime you remove vegetation from the banks, that increases the amount that can run off into the stream or river. All right, lakes often experience seasonal changes depending on the temperatures. In the summer, you have what is called thermal stratification. You have your warmer water at the top and your cooler water at the bottom. So if you look at this animation here, you can see the epilimnion is that warmer surface water. The thermocline is where the temperature suddenly drops off, and that's usually because that's the depth that sunlight stops, and then your hypolimnion is your cold water at the bottom. All right, in the fall, what happens? The surface water cools, it becomes more dense, and it sinks. And that's called the fall overturn. And this is important because it carries some of those nutrients from the bottom of the lake to the surface. In the winter, once again, we're going to get that stratification due to density. And in the spring, we have another overturn. The surface water warms. In springtime, we tend to have more wind, so it pushes the water to the shore where it's pushed to the bottom, once again causing that nutrient-rich water from the bottom to rise to the surface. In addition to bringing nutrients to the surface, dissolved oxygen is carried to the bottom, and typically the dissolved oxygen levels in the lake bottom are very low because of the absence of sunlight. You're going to have the absence of photosynthesis that's creating that dissolved oxygen.